The overall goal of this procedure is to produce ammonia from air, water, and wind-generated energy in a low-pressure process with negligible carbon dioxide emissions.
This method can help address key issues in ammonia production, such as reaction efficiency, product distribution, and carbon dioxide emissions.
The process uses a solid ammonia selective absorbent rather than a condenser. Continually removing ammonia from the system decreases the occurrence of the reverse chemical reaction.
The main advantage of this process is that it can be performed at lower pressure, which is safer and less expensive.
Corey Marquardt and I operate a plant for the conventional process that is 30,000 times smaller than typical plants. This gives a standard for comparison with the absorbent process.
Mike Reese and Corey Marquardt are operating the conventional small-scale plant in Morris, Minnesota. Demonstrating the absorption-based process will be Mahdi Malmali, a postdoctoral fellow affiliated with our laboratory.
Prior to beginning the process, start up the ammonia generation plant and ramp the catalytic reactor to 440 degrees Celsius. Set the condenser temperature to -18 degrees Celsius. Next, turn on the air dryer, the air compressor, and the nitrogen generator. Turn on the nitrogen gas booster to fill the nitrogen supply tanks. Turn on the chiller, water deionization unit, electrolyzer, and the hydrogen gas booster. Verify that the chiller is operational and cooling liquid is flowing through. Next, set the nitrogen